I am going to be taking us through a little journey through another galaxy and also unsupervised machine learning intuition. So, this is just building some intuition for unsupervised machine learning. In my previous video, we talked about the types of machine learning out there. We are going to zoom in on unsupervised machine learning and just give a very high level example. If you'd like some code to carry out your own unsupervised machine learning in Python, feel free to check out our free online textbook. We're going to zoom in particularly on a technique for unsupervised machine learning that is clustering. This particular table was made by Professor Sugars. Unsupervised machine learning is that we know the input X in our data, but we do not know the output Y. The idea here is we are trying to learn some underlying structures or relationships between our observations in our data that we might not be able to spot just by staring at it. You know, I love an ocular method, but sometimes it's just not enough. Enter clustering. We have observations in our data set made up of attributes or features, so X's or independent variables. We don't know the labels. We just know things about our customers, the animals that we see in a territory, things about the transaction that we're looking at data on, whatever it is that we have data on. We don't know the output. Maybe we have information about various symptoms of patients, but we don't know what disease they have. We just want to be able to look at all the patients and say, hey, could we cluster them in any set of groups that might be helpful to generate further discoveries? So we don't know the labels, and we may not know how many categories there are, how many diseases, species, whatever. What we want to do with clustering is learn the relationship between our features in order to identify similar groups of observations. So in principle, what we're doing is from this lovely graph, we're going from unlabeled data. In this case, it's kind of obvious where the clusters are. And we're going to run it through our k-means clustering algorithm, and it's going to give us labeled clusters. In other words, it's going to say, hey, green, blue, red, or clusters 1, 2, 3. It's up to us as researchers to say what those clusters actually mean. So we're going to focus on k-means clustering, which is probably the simplest algorithm. It's certainly the algorithm I love starting with when I talk about unsupervised machine learning clustering algorithms. So k-means, the core idea here is that observations in our data set of the same class, same type, will be clustered together in the feature space, and those clusters will be reasonably distinct. So feature space is a vocabulary word that's worth taking a moment to talk about. So feature space, if we have two features, the feature space is this graph with our X and Y axes. The feature space can be three-dimensional, and then we'd have a in a little 3D thing. It could be four-dimensional, five-dimensional. The core assumption is that differences in our features are descriptive of differences in class or category. For example, if I have data on, say, a body of customers for my online business, for every customer, I have how much money they spend with us, how often they interact with our social media posts, and how they review us online. I want to say, hey, can I identify different clusters in maybe, say, my types of customers? And maybe I'd want to target them differently. Our core assumption, if we're going to apply k-means clustering, is that the differences in those features that I have tell us something about differences in that class or category. This is both very obvious, but also very subtle at the same time. So it doesn't work if I think that the information I have won't help me differentiate them in a meaningful way. So for example, if I have data on whether they buy shirts, pants, or shoes, and I don't think that my customers are actually segmented in that way, like, oh, I'm going to target my shirt buyers, then the whole thing falls apart. It really relies on our underlying knowledge or ideas about what might be going on in our data. So the algorithm works as follows. So we humans choose the number of clusters K. How many clusters are we going to choose? I think my data has 2 clusters. I think my customers can be reasonably divided into 3 clusters. I think there are 4 species in my data set. We're making a guess. All right, I'm going to choose the number of clusters K. In this case, I've chosen 2. I'm going to select K random points and assign them as centroids. I'm literally going to say, hey, computer, here is my scatter plot of my data. In this case, we have 2 attributes. I'm going to set K equals 2, randomly pick 2 spots. So in this case, the computer has picked spots far away. They could literally be anywhere in the feature space. Assign each data point to the closest centroid, and I am going to label my data in a way that reflects which centroid it is closest to, and then I'm going to compute the centroid of the newly formed cluster. Whoa, a lot of words. What's happening? We are going to visualize this in mere moments. We are going to then repeat this until the centroid location is stable. That's it. There it is. So here's what's happening. We are saying, okay, 2 clusters, randomly place those clusters, call them centroids. Then we're going to say, okay, shade the observations in my data set according to which cluster they're closest to. So if they're closest to the red cluster, shade them as red. If they're closest to the blue cluster, shade them as blue. Now find the center, literally spatially, of the new cluster and move the centroid there. Then do it again, reshade according to which ones they're closest to, and do so until it is stable. And in other words, we don't see any movement. There is nowhere else to go. We found the center. How do we evaluate whether we did it right? Was that useful? Well, unsupervised techniques do not use a train or test split, usually because we don't have any output variables to compare our predictions to. We don't know the true label, so how could we predict a label or train on something like that? Validation really relies on theory. Do these clusters make sense given what we know? One way to validate is we could say, okay, given that the clusters are stochastic, maybe they're random because I'm putting the centroids wherever I please. Does my data cluster in the same way each time, regardless of where I start my centroids? And if you get similar results, you say, okay, these clusters probably mean something in the data. Students often get confused about the distinction between KNN versus k-means. So I want to take a moment to work through these. So in KNN, that stands for K nearest neighbors. That is an algorithm to conduct supervised machine learning. Specifically, we tend to use it for classifiers. In k-means, what we just looked at, what we're doing is we're partitioning observations into K clusters based on similarities in the feature space. This is unsupervised machine learning. It's a clustering algorithm. KNN, it's supervised, which tells us we have labeled data, as in we have a column in our data set that labels the observations as belonging to a particular class or category. We have the outcome variable for our data. In k-means, we use k-means when we have unlabeled data, no information about what class or category, but we think there might be one. So for example, in our customer base data set, if I have data that says, here's how much money they spend, here's how much they interact with us online, here's how positive or negative their reviews of us are, and I have data that says they're a loyal customer, an advocate customer, a discount only customer, and I want to predict new customers in terms of what class they are, supervised. If I don't know what type of customer they are, and I want to say, could I divide these into different types of customers? Unsupervised. You can think of k-means or unsupervised machine learning in terms of no dependent variable. We have all these attributes and all these features, and we want to find out if there's a way to usefully divide up the data into clusters. So to give you a more concrete example, suppose I have data on a bunch of cats and dogs at, say, a shelter. I have recorded their height, I have recorded their weight, and I have recorded what species they are. So if I have data that looks like the KNN data here, I have the height, I have the weight, I have the species. Suppose I get a new entrant into my shelter, and I know the height of this animal, and I know the weight of this animal. My KNN model could predict, is it a cat or a dog, based on this existing historical data. If I run a shelter and I'm new to planet Earth and I don't know anything about cats or dogs, and I just have data that says, hey, here are the heights of these creatures, here are the weights of these creatures, I could conduct a k-means analysis or another unsupervised cluster analysis to say, could we divide these creatures into two different types? And it would emerge, or I would see from my centroid exercise, that I have two different types of animals, and it would be up to me to name them as the small ones or the big ones or the cats or the dogs. So that's the idea. I hope this helps you build an intuition for what we're doing with unsupervised machine learning. Check out the textbook for code on how to implement it step by step. Thank you so much for being here, and we will see you next time.